Dear students, in the last module we studied about the photography and the basic principles of photography. In this module, we shall be studying about what are camera lenses and their types, various terms of the lens and various types of filters that are used in photography. First, the introduction to camera lenses. Camera lens is a transparent medium, usually glass, bound by one or more curved surfaces, spherical, cylindrical or parabolic, all of whose centers are on a common axis. A simple or thin lens is a single piece of glass whose axial thickness is less compared to its diameter, whereas compound lens consists of several components or group of components, some of which may comprise of several elements cemented together. Lenses are mainly divided into two types, with convex lens and the concave lens. First, the convex lens. This type of lens is thicker at the central portion and thinner at the peripheral portion. It casts real image and so can be used to take photographs. Convex lens can be divided into three types: biconvex or double convex, plano-convex, and third is concave convex or meniscus. Second type is concave lens. This type of lens is thicker at the peripheral portion and thinner at the center. It cannot cast real image, so as a single concave lens cannot serve the purpose of photography. Like convex lens, this type can be subdivided into three types. First, biconcave or double concave lens, plano-concave and convexo-concave. In modern cameras, both negative and positive lenses are used, but the net effect of the combination should be positive. Now we will discuss about the useful terms of the lens. First, the optical center. It is a point within the lens through which light passes undeviated or without changing the travelling path. Second, principal axis. The axis passes through the optical center of the lens, which is horizontal when the lens is placed vertical to the horizon. It is the stroke linking the centers of curvature of its surfaces. Third, focus or the focal point. When analogous beam of light passes through the positive lens analogous to the principal axis, then it converges at a point and it seems to diverge from a point in case of a negative type lens. This point is known as focus. Fourth is the focal length. The space between the optical center and focus is known as focal length. Focal length, commonly measured in millimeters, and is the basic explanation of a photographic lens. Though it is not a dimension of the actual length of a lens, but a calculation of an optical distance from the point where light rays meet to form a sharp image of an object on the digital sensor or 35 mm film at the focal plane in the camera. The focal length of a lens is determined when the lens is focused at infinity. Fifth is the focal plane. The imaginary plane passing through the focus and perpendicular to the principal axis is known as the focal plane. Next is the F-number. It is defined as the ratio between the focal length and the diameter of the diaphragm. F-number, which is equal to capital F by D, where capital F is the focal length and capital D is the diameter of the slit or diaphragm. The intensity of a lens is given by an arrangement of focal length and its diameter. In case if the focal length of any two lenses is found to be identical, then the lens having greater diameter will be brighter. In an instance, the focal length is 50 mm and the lens diameter is 17.8 mm, then focal length divided by lens diameter gives the lens of maximum f-stop of 2.8. Then types of photographic lenses. Photographic lenses are divided into various categories according to their focal length, specialty and use. Although modern compact cameras come with integrated lens with variable focal length, however, only SLR cameras have the advantage where one can change and use almost any type of lens according to their requirement. The diagram shows how change in focal length determines the angle of view of the lens. First, normal lens. The standard lens has a stable focal length which is 50 mm or 85 mm and imitates exactly what the human eye sees in terms of viewpoint and angle of view. For a 35 mm film camera or a full frame DSLR, the 50 mm lens is considered as standard. Next is wide angle lens. A wide angle general has less focal length 10 mm to 42 mm in relation to a standard lens. This enables us to seize a relatively wider angle of view. A wide angle lens is a natural choice for capturing outdoor landscapes and group portraits. In fact, wide angle can be the only way to capture the complete setting without omitting important elements in the image. In this manner, we can use wide angle lenses to capture a deep depth of field. Then is telephoto lens. Telephoto lenses, which are 100 mm to 800 mm, provide a constricted field of view. These extended lenses allow compression of distance and constricting the sense of depth and take view of a particular object from distant. They have a good resolving power as well as an inherent shallow DOF, where even the minor later movement can take a subject out of focus. Then next is zoom lens. Zoom lenses are beneficial because they allow for an array of different focal lengths lacking the necessity to transfer various prime fixed focal length lenses. This allows the photographer to quickly zoom in and capture the shot, the zoom back for a wider angle. While this is a wonderful advantage, there are optical limitations that should be understood when using a zoom lens. Each lens possesses a maximum aperture or lens opening used for capturing the light. On most zoom lenses, the maximum aperture can change as we zoom and the optics move to focus at the fresh zoom setting. These zoom lenses are said to possess a variable aperture. To attain the widest portable aperture, we are required to use widest zoom setting. Next is close-up or macro lenses. Close-up or macro lenses are used for close-up or macro photography. The focal length ranges between 50 to 200 mm. These lenses accomplish razor sharp focus for objects in the macro focus distance, although they lose their capacity for sharp focus at far distance objects. These lenses permit the photographer to achieve life-size or larger images of subjects like wasps, butterflies and flowers. Next is fisheye lens. A fisheye lens is a specialized wide-angle lens that provides extremely wide images by altering straight lines into curves. It occasionally forms circular, convex or oval pictures by altering the viewpoint and forming a 180-degree image. The range of focal length differs from 7 to 16 mm in a fisheye lens. Next type of lens is tilt-shift lens. The tilt-shift lens permits us fluctuate the vanishing points. If you are firing buildings, you can modify the perspective of an image so the parallel lines don't converge, thus eliminating the distorting quality of the lens. The tilt-shift lens also allows us to desirably focus on an image where only particular parts of the image are in and out of focus inside the same plane. Now we will study about the various defects of lenses. First is spherical aberration. Spherical aberration is an optical complexity which arises when all inward light rays terminate focusing at diverse points, later passing through a spherical surface. Light rays passing through a lens near its horizontal axis are refracted lesser than the rays nearer to the edge or periphery of the lens, and as a result they end up in different spots across the optical lens. Then second is chromatic aberration. Chromatic aberration, also known as color fringing or purple fringing, is a common optical problem that occurs when a lens is either unable to bring all wavelengths of color to the same focal plane, or when wavelengths of color are focused at different positions in the focal plane. Chromatic aberration is caused by lens dispersion with different colors of light travelling at different speeds while passing through a lens. Third is Koma. Koma is an aberration which causes rays from an off-axis point of light in the object plane to create a trailing comet-like blur directed away from the optic axis. A lens with considerable Koma may produce a sharp image in the center of the field but becomes increasingly blurred towards the edges. Fourth is the astigmatism. Astigmatism or pointlessness is a refractive error which occurs when a point sending light through a lens cannot be projected as one point. It appears as a line on the focal plane. Another explanation is that astigmatic lenses fail to represent in the vertical line form into the same image plane. This effect mainly appears when the biconvex or biconcave lens elements are used. It has been observed that all lens defects can be minimized by combination of positive and negative lenses and modification of design and coating. Next, we will study about the filters for photography. Filter is a device of glass or other material interposed between the scenes being photographed for the purpose of deducting or eliminating certain colors, generally to which the film is most sensitive, also called a color filter or optical filter. Generally, two types of filters are available that are as follows. First is colored glass filter and second is gelatin dye sandwich filter. There are 5 main types of filters as per their usage. First is correction filter. This is used to correct the imperfect color sensitivity of the film and make it translate the subject into tones of grey and the same brightness as the colors appear to the eye. It is also used in the color to achieve desired color temperature. Filters do not really enhance color but only absorb various wavelengths to upsurge the relative proportion. So, the initial light source must have the colors in it which we want to start with. Some sources which lack various wavelengths will not be added back using only filters. This is particularly true of many types of metal halide lighting. With other lighting categories such as fluorescent, color temperature, quantities, it will not make available the correct filter necessities. Subsequently, color temperature theory is based on having a continuous spectrum, meaning light at all wavelengths. Second is contrast filter. This is used to darken the reproduction of a certain color for special effect. There are many circumstances such as bright sunlit exteriors where proper contrast is difficult to maintain. Exposing to highlights or darkness will leave the other under or overexposed. Low contrast filters create a less amount of localized flare near highlight areas within the image. This reduces contrast by lightening closed shadow parts, parting highlights almost unaffected. Soft contrast filters comprise a light absorbing component in the filter which, when deprived of exposure compensation, will decrease contrast by darkening highlights too. Use this later filter when lighter shadows are not according to the need. In both cases, the mild flare created from bright highlights is mostly used as a lightening effect. Then third is red filters. Red filters forms strong effect and significantly enhanced contrast. They are generally considered as too harsh for various types of photography. However, they can be used to create remarkable creative effects. Next is orange filters. Orange filters falls between red and yellow filters. It forms a nice balance of each one's properties. Last, yellow filters. Yellow filters produce the most subtle effect of the 5 colored filters. In most of the cases, difference is hardly evident, although it can help us to lift a photo. Next is color compensation filter. Color compensating filter is used to make adjustments to the red, blue or green characteristics of light. These are applied in correcting for color balance, light source variations, different reversals, film batches and other color effects. They are available in density variations of cyan, magenta, yellow as well as red, blue and green filters. Now special purpose filters. It is used to take picture by the light of a single color only. These are mainly used for scientific, aerial and other special photography as telephotography in infrared. Next type of filters are infrared filters. In special circumstances, we use black and white or color infrared sensitive films. For aerial haze penetration, recording heat effects and forensic photographic, their color and tonal renditions are very diverse, though from other film types. Various filters are used to diminish undesirable visible light. Red, orange and yellow filters used for panchromatic black and white film can enhance contrast and alter the color. Next is neutral density filters. When it is intended to uphold a specific lens opening for sharpness or depth of field purposes or merely to get appropriate exposure when exposed to high intensity light, neutral density filters are used. This will absorb light consistently all over the visible spectrum, efficiently fluctuating exposure without needing a change in lens opening and without presenting a color shift. Next type of filter is polarizing filter. Polarizers allow color and contrast enhancement as well as reflection control using optical principles different from any other filter types. Most light that we see is reflected light that will take up its color and amount from the matters we are looking at. White light as from the sun reflecting off a blue object appears blue because all other colors are absorbed by that object. A small part of the reflected light reflect back the object without being absorbed and highlighted, holding the original color of its source. Next is filter factor. This is the relative increase in exposure required when an optical filter is used. The filter factors will not always be persistent number. It depends on the color of the filter as well as the hue and saturation, the color sensitivity of the film, the color of the light and the color of the subject. Generally, deeper the source of the filter, higher the filter factor since it restricts more amount of light. Manufacturers advise should be followed to get desired exposure. Exposure value compensation is usually given in half or whole number such as half x, 2x, 3x, etc. Next is film sensitivity. Orthochromatic films are sensitive to UV, blue-green and slightly towards green of the spectrum. Fast orthochromatic films are sensitive to yellow-green and slightly towards yellow as well, but to a great extent to violet and blue. Panchromatic films are sensitive to all colors. Now colors of light. Daylight is more blue and has higher color temperature than the tungsten lamp. Blue filter can reduce the tungsten lamp effect. it should be noted that color temperature of daylight depends on the time of the day, weather and season. All films are oversensitive to blue, so subject like landscape, blue sky is much too light or towards the white in the final print. The tone and the details between the sky and the clouds are almost lost. This difference can be reduced by using a yellow filter. Orange-green filter often is used in daylight for proper tonal compensation. Then artificial light. The most common lighting tools used today are tungsten light, fluorescent light, HMI light and electronic flash. Each technology has distinct advantages and disadvantages. While I will discuss each in detail, all have one key drawback in common. They are essentially fixed in terms of color temperature. Because the color temperature is fixed, these light sources are not able to emulate the overchanging nuances of natural light. Digital cameras typically have presets for daylight, flash, tungsten and fluorescent light sources in an effort to arrive at pleasing results under these traditional illuminants. Now electronic flash. Originally all flashes were manual in operation. That is, depending on the power of the flash, the distance from the subject and the film speed, we had to find the proper f-stop to use. If we moved a few feet, we had to calculate a new f-stop. In the 1960s, Honeywell pioneered the automatic flash. This was quite an improvement. For now, as you moved around, the flash automatically provided the proper amount of light. This was accomplished by adding a sensor to the flash unit. As light travels to the subject and bounces back towards the flash, the sensor measures the light and quenches the flash when the subject has received enough exposure. Automatic flashes are highly recommended. Most modern flashes have 3 to 4 different automatic ranges, allowing different f-stops and working distances. They can also be placed into manual mode for certain effects. Now we will conclude with the summary. First, camera lens is a transparent medium, usually glass, bounded by one or more curved surfaces, spherical, cylindrical or parabolic, all of whose centers are on a common axis. Second, the distance between optical center and focus is called focal length. Focal length, usually represented in millimeters, is the basic description of a photographic lens. Third, if the focal length of two lenses is the same, the lens with the larger diameter will be brighter. Fourth, when it is desirable to maintain a particular lens opening for sharpness or depth of field purposes or simply to obtain proper exposure, when confronted with too much light intensity, neutral density filters are used. All films are oversensitive to blue, so subject like landscape, blue sky is too light or too white in the final print.